Okay, we're going to look at converting degrees to radians. So basically, the degrees in a circle are represented as 360 degrees is one rotation, okay? If I were to go angle-wise, go all the way around once, that's 360 degrees, okay? We talk about in the Olympics, when you hear this, the snowboarders and the skateboarders, a 360 is one rotation. A 720 would be two rotations. If I were to start here and go around twice, that would be a 720. So every full rotation is 360 degrees. So what I'm going to do is I want to take these degrees, which represents the angles. So for example, there's a 90-degree angle. That also means that's a 90-degree arc. Okay? What would this angle be from the start? This is 0 degrees. That would be 180 degrees. That's one half of the circle. You've talked about doing 180s all the time. Okay? 360 is all the way around. So anyway, that can kind of show you how it works. Okay, so degrees, there's 360 in the circle. Okay? There's 360 degrees in a circle. And the degrees have to do with the arc and angle measures. Keyword there, measures, okay? What the radians are, if I want to convert to radians, is I'm looking for radians. Radians have to do with the circumference of the circle, okay? There are 2 pi radians in a circle. Now what is the formula for circumference? 2 times pi times radius, right? This is the unit circle. The unit circle has a radius of 1. That's your base circle. So if I wanted to find the circumference of this circle, I would be 2 times pi times my radius, which is 1, right? So what is the circumference of the unit circle? 2 pi. So the question is, how do I convert the number of degrees to the number of radians? Now, the radians has to do with arc length. Arc length, okay? This is the length of the arc, not the degree measure of it, but its length. So the radians is the arc length. So the 2 pi, half of the circle at 180 would be pi radians. That's half the circumference. Half of 2 pi is pi. And the full circumference over here would be 2 pi. That's one full revolution. So if I want to convert from degrees to radians, I'm taking basically the measure of the angle and converting it to the length of the arc. So, sorry, messing all that up. So let's do a couple of examples. All right, so number 1, let's say I've got 135 degrees, okay? And I want to convert 135 degrees from degrees to radians. Now, keep this in mind. I'm going to do an example. I did this example on the conversion from degrees to radians to degrees also. I'll do it on there. But let's say you have 2.5 feet and you want to convert that to inches. I'm just showing you what we're doing here, but using a different context. So what do? This is basic conversions that you learn usually in science when you're doing scientific conversions. 2.5 feet. If I asked you guys how many inches are in 2.5 feet, most of you would say, oh, that's easy, 2.5 times 12. Okay, why is it 2.5 times 12? Well, when I multiply, what I want to do is I want to cancel out the units. So for example, 2.5 feet. How many inches are in 2.5 feet? 12. There's 12 inches in 1 foot. 12 inches in 1 foot. Now what does that create for me? Well, what can cancel now? If I multiply across, I get feet and inches on top and then feet on the bottom. So what goes away? Feet. So I'm left with 30 inches. And that's how I convert from feet to inches. Notice if I'm going from one unit to another, whatever unit I'm starting with goes on the bottom of my conversion factor. Okay? So let's go the other way with this one. Let's say I have 30 inches and I want to convert that to feet. Well, that's great. 30 inches. And then remember, the conversion factor you're using has to go, what you're converting from is on the bottom, so 1 foot to every 12 inches, right? That makes sense? Of course, you answered me. You can't answer me and I can't hear you, but I'm going to assume you said yes. So 30 inches times 1 foot, again, we would have inches times feet on the top and inches times inches. So I'm going to end up with 30 feet over 12, and that's going to equal 2.5 feet. So you can see how I perform those conversions. I use conversion factors. Well, let's use conversion factors over here. I'm converting from degrees to radians. So what I'm converting from needs to be on the ground, on the bottom. So I'm going to put pi, I'm going to multiply by pi over 180. Now, why would I do that? Well, because there's pi radians in every 180 degrees. Now think about that. Pi would be half of 2 pi, right? And 2 pi is 1 revolution around the circle, the unit circle with a radius of 1. Well, half a revolution instead of 2 pi would be pi, right? What's half of 360? If 180. So the degrees and the radians kind of match up. So now I have 135 pi over 180. And all I'm going to do is reduce that, and I don't like thinking and having to reduce. So let's think of what I can divide both of these by. I can actually divide both of them by 45. 45 goes into 135 3 times. So I have 3 on top, and the pi stays there. And 180 degrees has 4 45s. So there's my answer. 135 degrees represents 3 pi over 4 radians. Okay, so let's look at another example. I know y'all are really enjoying this. So let's look at example 2. I want to convert 270 degrees to radians. So what am I going to do? Well, what's my conversion factor? Well, since degrees is on top, degrees will be on the bottom for my conversion factor. And there's pi radians for every 180. Half a circumference for every 180. So I multiply, and I've got 270 pi over 180. And 90 actually goes into both of these. 90 goes into 270 3 times, and it goes into 180 twice. So that's 3 pi over 2 radians. So that is how you convert from degrees to radians. Okay? Now, one thing that we need to talk about is negatives. And I'm going to do some negatives here. You can have negative degrees in a circle. Not that you're measuring negative degrees, but it's directional. What if I wanted you to convert negative 540 degrees to radians? I'm not saying that you're going to have negative degrees, but what that means is I'm going to go this direction. It would probably help if I showed you the circle. Instead of going this way until I hit 540, I'm going to go this way until I hit 540. So we're going to go backwards. So you need to count. You're going backwards. That's what the negative means. Negative 540 is not the same as positive 540. Here's an example. Let's say I have negative 90 and I have positive 90. Those are not the same thing. Why are they not the same thing? Think about it this way. Positive 90 means starting at 0 and going up to 90, right? Negative 90 means starting at 0 and going down here. Those are 2 completely different spots on the circle. The negative and the positive tell us direction. So if I do a negative 90, I'm this way. If I do a positive 90, I'm this way. So you've got to be careful with all the negatives. So let's come down here and let's convert that negative 540. The negative 540, I do the same thing. I'm converting from degrees, so the degrees needs to be on the bottom. It's still pi radians for every 180 degrees. So I'm going to multiply across, and I've got negative 540 pi on top and 180 on the bottom. And again, I need to reduce. So I'm going to do 90 again because 90 goes into both of these. So I get negative 6 pi on top and 2 on the bottom. Okay? So negative 6 over 2 equals negative 3 pi. So that's how I convert. I can get a negative radian measure. It just means on the circle, instead of going positive direction, I go negative direction. So you're going to end up in different spots, okay? One more example. Let's say I did 270. 270 is also 3 pi over 2, okay? If I do positive 270, which is positive 3 pi over 2, that means I go this way with full sound effects. I end up right here, right? All right, let's do the complement of that. Or not the complement of that, but let's go the opposite way. Now I want to do negative 70 or negative 3 pi over 2. So instead of going positive, I'm going to go 270 this way. 180, 270. That's negative 270, which is the same as what? Positive 90. So you can see that the sign, all the sign does is indicate direction, and that's how you convert from degrees to radians. You're welcome.